All right, yesterday most of y'all did pretty well finding the equations from graphs. So we're going to add a little bit to this today. We're going to find the slope from 2 points. And by points, I'm talking like ordered pairs, okay? So the coordinates. Eventually, we'll have to get a whole equation from the 2 points, but, we'll start with slope. So first, when we have a graph, how do we find the slope on a graph? Rise over run. So slope is rise over run with a graph. When we have rise goes up and down, right? Run goes left to right. So what that is, which axis goes up and down then? Y. So our y-axis is working with the rise, x-axis is working with the run. So when we use ordered pairs, the y values are going to be the rise. That means they're going on top. X values on the bottom. They're the run. And basically what we're doing is the change in y over the change in x. So from one y value to the other, how much does it change? One x value to the other, how much does it change? So here's how this works. First thing we always have to do is we have to have our x's and y's correct. All right? What are my y values? 5 and 19. It's x first and then y. So for my change in y, my y values are 5 and 19. That means I am going from 5 to 19. For my x values then, I've got -4 and +3. The order has to match. The x value or the y value that's first, the corresponding x value also has to be first. So since 5 was first, that means -4 has to be first. Okay? The order on the points doesn't really matter a whole lot as long as it's the same and consistent with the corresponding ones each time. So the x's are going from -4 to +3. Okay? Anybody got any questions about how I set that up? It's just the change in y over the change in x. So from 5 to 19, how far is that? 14. When the signs are the same, basically you end up subtracting the two numbers to get the distance between them. From -4 to +3, how far is that? Yeah, that's a distance of 7. When you go from a negative to a positive or a positive to a negative, you got to stop at 0 first, right? So we're going from -4 to 0, then 0 to 3. That's a total distance of 7. You basically end up adding the two absolute values when you're finding the distance between a negative and a positive. Okay? Yo, what's 14 over 7 then? 2. That's my slope. There's my slope. That's it. All right. Change in y over change in x, and then you might have to do some division or simplify a fraction. Any questions on this so far? All right, so let's look at it a little different. What are my y values this time? 4 and -12. So we're going from 4 to -12. X values from 3 to -5. 4 to -12. How far is that? 16. Now here's a part that's a little bit trickier with this. From 4 to -12, we are going down. We're decreasing, right? If we are going down, we need to make that a negative number. All right, so it's not just the distance. All right, distance is always positive. you kind of get the distance, but if it's decreasing, we need to make it negative, okay? From 3 to -5, how far is that? 8, and then again, that's going down, so we're going to have a negative. If both sides are negative, the slope is, so if the side is the same, it's going to be positive. If the side, doesn't matter if it's the change in y or the change in x, if one of them is negative, the whole thing's negative, okay? If they're both negative, it's positive though, okay? So -16 divided by -8, 2 again. They're not all 2. I just happened to pick numbers that made 2 both times. Any questions on that? If they're both negative, it's going to be a positive for the slope. All right, so my y values, where are my y values here? -13, and we're going to -4. X values are going from 6 to 9. All right, from -13 to -4. This is where you got to be careful sometimes with the numbers. From a negative to a negative, you subtract the 2 numbers, okay? So 13 minus 4 is 9. So that's a 9. Are we going up or down to go from -13 to -4? Is that increasing or decreasing? Increasing, so that's a positive 9. We're getting closer to 0, getting closer to the positive numbers. From 6 to 9, how far is that? 3. And that's obviously, or hopefully obviously, going up. What's 9 over 3? There's our slope. All 3 of the examples I did happen to be whole numbers. You will get fractions a lot for this though, okay? Improper fractions are okay. They're kind of better than mixed numbers. Any questions? Not so bad, right? All right, y'all try these 2. Both of these will be fractions. All right, the one on the left. Heaven, what you got? 2/3 is correct. So changing y over changing x. Y values are the 4 and the 6. X values, then we're going from 2 to 5. When the signs are the same like this, you're subtracting those numbers. So from 4 to 6, that's a distance of 2. 2 to 5, distance of 3. All right, second one. Brian? -3/2 is correct. So we're going from 3 to -3 for the y values. The change in x is going from -2 to +2. From 3 to -3, how far is that? 6, and it's decreasing, so that makes it a -6. -2 to +2, that's a distance of 4. Some of y'all had that, and we're stopping there. We should try to simplify if we can. 2 goes into both of those numbers, so that's where the -3/2 comes from. All right. There are some problems we'll do eventually where you might have to have that as 1.5. For the most part, improper fractions are okay with just like the ordered pairs like this. Yeah. That's only if it's going to be like a whole number. Do that. Any questions on that?